Hi all, thank you for tuning in to my ozone technology course. This course is session 18, ozone application in sewerage treatment. This session will introduce you to the fundamental knowledge for the treatment of sewage with ozone. The traditional methods are still being used where there is space and abundance of water. Ozone in sewage treatment can be used to recycle the water as grey water and save the drinking water. The treatment system is very similar to that of the previous traditional system, except there will be an introduction of ozone in certain categories. The first process is the filtration, that is using the sieve or skimmers to remove the solids, tissue paper. There might be any oil or grease that might be there also can be removed through an overflow, so that only the protein suspended fecal matter will be directed to the next stage. The next stage is the pre-ozonation process. This is where ozone will be introduced, and the purpose of that ozone is to break down the large proteins to small chains. The next stage, the water or the mixture goes into the next tank where biodegradation or digestion takes place. This is very similar to the traditional method, and one difference is the bacteria that is digesting this material have less work to do because all the long chains of proteins have already been broken down to simple smaller chains. The work they don't have to do, and therefore time is saved. So the time factor for biodegradation is reduced considerably because, as I did say, the bacteria needs no time to break the larger chains to the smaller ones, as it has already been done for them by the ozone. Then there will be a filtration of undigested methods in the time provided. For example, some cellulose. In some setups, this can be taken back to the sludge and again digested until more of the solid matter can be broken down. The last stage is the sanitation, and this is where actual ozone is used. The ozone is pumped in. This slide is a diagrammatic presentation of the treatment system, sewer treatment system using ozone. The sewage water that comes in from the houses will be taken to the sieve screening or sludge, skimming of the oil and grease, and the clear sediment water or sewage water will be directed to a separate tank. It could be about 10 megaliters tank where the sewage water enters. Now, the difference between the old treatment system and the ozonation system is at this stage where from the ozone generating system, ozone is pumped through into this tank through small atomizer disk that will be distributed throughout the tank. So the atomizers will produce the ozone gas that bubble upwards into the tank. And as usual, there will be a skimmer or a mixing arm that will very slowly mix the water so that the ozone is contacted with every part of the mixture. One thing we must know is the amount of ozone that is going through this atomizer disk is not high but very, very low. The purpose why it is low, because if the ozone content is high, concentration is high, then the bacteria will be destroyed, and when it goes into the biofermentation tank, there won't be any bacteria formed. So with the small concentration, often in the amount of below 0.05 ppm or so, you will have the first attack of ozone will be the protein matter rather than the bacteria. Once it has been reasonably broken down, it could be in a matter of half a day or so, this pre-ozonated sewage will be directed to the biofermentation tanks, and this is where the bacteria will continue to break down the smaller protein particles to soluble nitrates, sulfates, etc. And the carbon is broken down to carbon dioxide and smaller molecules. Note that the pre-ozonation will not have a very high concentration of ozone there, but it may also flocculate some small particles, and that might come out into the sludge. Also, what is left over in here on the sludge settled will be taken to the sludge so that it can be either recirculated for treatment or taken out as dry, sterilized material for fertilizers. So the broken down sewerage, once it's directed here into these stages, the bacteria commence the fermentation, and fermentation is much rapid because of the fact that most of the digestion has already taken place by the ozone. Once the digestion is complete, then the top surface water is taken through the sand filter, filtered, and goes through the ozonation process. Here, the ozonation process the purpose of this is to disinfect. In other words, all the bacteria that has been in this system here, including harmful bacteria, will be killed by ozone. and the amount of ozone applied will be to make sure there is at least 0.1 ppm effective concentration, which will destroy all the bacteria, virus, etc. And by the time it comes out in this section of the pipe, it will be clean and can be pumped to the river. Alternatively, it can be stored, close storage, and then used for potable water or back to the stream. Please note that the ozone disinfection process will, if applied properly, guarantee that there will be no bacteria, harmful bacteria in this system, and therefore this water will be as good and clear water as that of our drinking water. There is a psychological aversion by the public not to drink the water that has been obtained after the sewer treatment. But let me tell you that this water will be even purer and better and more tasty, or without any bad odor, than that of the normal drinking water. This is another diagram of the ozone disinfection. As you would notice, this is where the grit sieves cleaning exercise takes place. There will be a clarification where the sludge is reconditioned, mixed, and ozone is pumped in through here, as because it is pre-ozonation, it will be a very low concentration. Then the digestion will continue taking place with bacteria, and again the sludge is removed and can be recycled. For example, the sludge, digestion of the sludge can continue here, and the water removed from the sludge or dewatering, the dry sludge is taken for further sterilization before it goes to the garden markets as fertilizers. The sludge water can be taken back to the pre-oxidation process or pre-ozonation process and continue towards filtration. And once it's filtered, the filtered water is further disinfected with your ozone. This is the final disinfection, and the concentration of this session ozone system is much higher than the one in pre-ozonation. Also, you would note that ozone can be, if there's any anaerobic actions that take place here, which will cause any smell, that smell can be further broken down by a small amount of ozone that you put in, so that the smell that comes out will not be of any bad odor. The advantage of using ozone is as follows. First, it removes color and odor completely. So the water will be perfectly colorless and clear. Ozone will disinfect the water thoroughly from microorganisms such as bacteria, algae, fungus, virus, etc. Ozone treatment also reduces the biological oxygen demand and the chemical oxygen demand. The biological oxygen demand is increased by proteins that can be oxidized or oxidized by digested by bacteria. So if you after the digestion, we use ozone treatment to remove the protein material of the bacteria. Of course, ozone reacts with quite a number of chemicals that can be oxidized, and therefore the chemical oxygen demand is also reduced. Removal of organic, inorganic matter. This is of course related to both the BOD and the COD. The organic material causes the increase in BOD. The inorganic matter causes the increase of the COD. Enhancements of the flocculation, coagulation process. Because of the fact that the ozone denatures protein, soluble protein, the denaturation process will result in either flocculation or coagulation, so that the precipitate will settle. You can just decant the water, leaving the precipitate as a sludge. We also must realize ozone is produced on-site through the ozone generator, and therefore there is no requirement of storage of dangerous chemicals. Ozone also oxidizes metal and non-metals such as iron, arsenic, manganese, hydrogen sulfide, and all other organic material, which chemical treatment will have much difficulty. There's also no refilling, no consumables, no replacement, and very low maintenance if the ozone system is used for the treatments. The time of operation is given for each of the stage below. The first stage is sieving and filtration. This can be continuous. That means as the sewage goes into the tank and mixing takes place, the filtration through the sieve is continuously done, and the same thing with the ozonation. In the traditional stage, pre-ozonation phase does not exist, but what they do is they may add chemical additives. The purpose of the pre-ozonation is effective flocculation. It will not kill bacteria because the amount of ozone put in is very low, and there will be a preference of breaking down the proteins to killing the bacteria. So actually, pre-ozonation pre-digests the sewage so that in the biodegradation fermentation process, the bacteria will digest. So if there is no pre-ozonation, the digestion per tank will take about 5 days. If pre-ozonation takes place, the time of the complete digestion can be reduced as much as by 50%. This means there's less less space required or less number of tanks required with ozonation compared to the traditional methods. Filtration is continuous in both cases. Post-ozonation is also is continuous. In the traditional case, they use chlorine, whereas in this case, ozone can be injected to give online so that there is complete disinfection. Whereas here, there's not ozonation, it is chlorination. So there is a possibility of bacterial regrowth, and there will be no bacterial regrowth here. So the only requirement compared to the traditional treatment will be the ozone equipment with pump, compressed air system, which will be there even for the traditional system because they have to aerate the system. In pre-ozonation, the ozone and air mixture is fed through the diffusers or sieve plates located at the bottom, at the floor of the tank. When the resultant treated water is sterilized, ozone is fed online, and to the extent of approximately maybe 0.1, 0.5 to 1 ppm. This guarantees that the water is totally sterilized and clear. The advantages of application for ozone are as follows. As I did explain to you, it decolonizes and the water will be clear. It destroys all the microorganisms, bacteria, algae, fungus, and various virus and cysts. Ozone treatment reduces COD, BOD. Ozone oxidizes, break down organic material, precipitates the non-organic salts. And including iron, arsenic, and manganese. But please note the manganese can redissolve if the ozone is in excess, and which will become permanganate. Therefore, permanganate. And therefore, we have to make sure that we don't overdose. If it is known that there is a very high quantity of magnesium salts in there, or manganese salts in there. Ozone flocculates to colloidal solutions, both organic and inorganic, and can be removed by filtration. Ozone produced on site. It has got a very short half-life, and therefore it is not, that cannot be stored, but and so not require any storage space and toxic and corrosive chemicals. And ozone application requires no consumables. You can save tremendous amount of cost. So this is just a summary of the treatment. There is something interesting that I would like to explain with respect to United States. US is a leading country in the world, and many other countries tend to follow whatever the United States does. However, in United States, much of the policies are dependent upon the Congress and the Senate, which are actually influenced and controlled by big, large corporations who actually support all the senators and Congress through funds for the elections. In other words, many drug companies and chemical companies, for example, when they give funds for election purposes to the congressmen, whether it is Republicans or Democrats, if they do not want any particular laws to be passed, they would be able to persuade the Congress people not to pass them. The EPA is also influenced by these companies. Ozone is not much in use in the United States simply because this application technology is a severe threat to the chemical companies and the drug companies. Because ozone can substitute many of the drugs, and if it is applied effectively, many of the known drugs provided in the medical industry may not have much market. The same thing as chemicals in the chemical industries. Chlorine is one of the biggest products manufactured by the chemical industries that sells very well. With the advent of ozone, it's quite obvious these chemicals, particularly chlorine, the market will drop like a ton of bricks. That may be up to 50 to 70% of the earnings of such companies. So it is in the interest that ozone will continue to be suppressed. Let's have a look at the opinion of the EPA, which is influenced by the chemical and drug companies, and I will give you some of the contradictions. First, they said the low dosage may not effectively inactivate some virus and spores and cysts. That is totally untrue, because you have ozone plus additives, and ozone in combination with other oxidizing agents are extremely effective in destruction of cysts. In fact, like Giardia and other cysts, chlorine will not destroy them. But ozone with chlorine or ozone with other oxidation materials can certainly destroy these cysts and spores. So this information put up by EPA is not correct. The EPA, it just says ozonation is more complex technology than is chlorine and UV disinfection, and requires complicated equipment and efficient contacting systems. Well, certainly, application of ozone is not a complicated technology. Production of ozone is a complex, and currently it is getting cheaper. You can get more ozone per dollar than what you could 20, 30 years ago. And application is not very complex. Chlorine is a gas. The only question is it is very soluble, and therefore it's easier to apply the gas into the liquids, whereas ozone is less soluble, but still it can be effectively transferred into the liquid. The next, ozone is very reactive and corrosive, thus requiring corrosion-resistant materials such as stainless steel. That ozone is, of course, reactive. Ozone is not necessarily corrosive because before 1980s, chromate was used as a corrosion inhibitor, and chromate is a very strong oxidizing agent. So the only way it can react, it protects from corrosion, is by oxidizing the surface area of the metal to an oxide that will be resistant to water-based or any sort of corrosions. However, all the allegations of corrosions by ozone is reflected from the other forms of corrosion, such as electrolytic corrosions. So it is the electrolytic corrosion that is really the culprit, and ozone is being blamed for it. Ozone is very reactive in water. Corrosive issues are absent in sewage water treatment. Ozone has been very successfully used where iron pipes are used. The corrosion is no different than with chemicals. In fact, high concentrate of chlorine will cause more corrosion than high concentration of ozone. Ozonation is not economical for wastewater with high levels of suspended solids and BOD, chemical oxygen demand and total organic carbon. That is not correct. The capital cost may be higher, but is becoming less. Yes, in 20, 30 years ago, it was almost impossible to produce very high concentrations of ozone because the equipment was not capable of producing. But currently, we are able to produce hundreds of kilos of ozone per hour, and considering only a small quantity is required compared to the chlorine, that hundreds of kilos are more than sufficient for treating any form or any material. And further, in wastewater, we use pre-ozonation to break down protein material, and that will save the digestion time by more than 50%. Therefore, ozone is much more economical because there's a saving of time factor. In cities where the land prices are expensive, you have to use less tanks, and instead of allowing 5 days for complete treatment of the sewage system, we need only 2.5 days. That is obviously much better and saves a hell of a lot of money. Further, after the breakdown, the water can be reused. With chlorine, it cannot be reused because chlorine does not kill completely, and the residual bacteria can regrow to the same levels as before chlorine disinfection. The capital cost is getting less, running costs are cheaper. Ozone is not used for treating suspended solids, but to break the solids, organic solids, into smaller particles, making it easier for bacterial degradation. Ozone is used for pre-ozonation and final treatment only. Of course, there will be a lot of sludges that cannot be broken down. A good example is cellulose. Cellulose can be broken down by ozone, but it requires time and more concentration. Cellulose will not be broken down by chlorine. Therefore, in order to save time and cost, cellulose and other materials are removed as sludge, dried, and it can be reused after sterilization or heat sterilization as material for the garden fertilizers. Ozone is extremely irritating and possibly toxic, so off gases from contractors must be destroyed to prevent worker exposure. No doubt, it is irritating, and they say possibly toxic. Even the EPA is not sure whether it is toxic or not. It's more chlorine coming out of gases is more dangerous than the ozone. Half-life of ozone is very short in water. It may be a bit longer in air, but if it is used accordingly and calculated use, there will be very little ozone coming out in the off gases. Further, it can be easily destroyed by just a heated filament coil. The cost of treatment can be relatively high in capital and in power intensiveness. That is not true, because you use the same amount of power for the pumps, same amount of power for the aeration as you would for ozonation. The return of investment may be less than 2 years, and there is much less use of power, because in order to produce ozone in kilos, you will need less amount of energy and cost than you would if you have to buy kilos of chlorine. Hence, I would say that ozone is a much better, preferable option for most treatments than chlorine. So here you will notice that EPA has provided so much of information, and because they are authoritative, people tend to believe it as an authoritative. Obviously, this information that is put out by the EPA is influenced by the chemical companies, so that less people will start using ozone. This is an example where City of Montreal in Canada has installed an ozonation system at Jean R. Macote wastewater treatment plant in Rivière des Prairies. It is the world's largest wastewater treatment plant to use ozone as to clean water. Here, ozone does a better job of reducing the risk of waterborne viruses, bacteria, and cleansing traces of cosmetic and pharmaceutical products, industrial waste, which chlorine will not treat. Ozonation is 99% effective at removing fecal coliform and enterococcus bacteria in the sewer system, and a secondary ozonation will be able to remove the remaining 1%. Ozone treatment also does not require chemical additives to be mixed with water. The plant treats wastewater before it is returned to the river and reduces the contamination. I have provided you 2 references for you to read on ozone, and perhaps we will be able to understand better why ozone is still not a very popular application system. Thank you for the patience of listening to my sessions. This ends session 18 on ozone application for sewage water treatment. The next session 19 will introduce the traditional chemical treatment of swimming pools for destruction of bacteria and the disadvantages. If this session is your first tune-in, please refer to sessions 1 and 2, which is introduction and program details, and sessions 3 to 17 on the ozone technology course to date. Please click like and subscribe if you wish to be notified of future uploads. Thank you and have a good day.